Hello, I am back to talk about robotics and TCL/TK programming. In this second video, I will show the process of making a smart planter weather station. This video is not a step-by-step guide on building a smart planter weather monitoring device. I will show the hardware modules that I use together with Arduino Nano 33. I will also show parts of the firmware and software. It will just be enough information to help some of you get started, I suppose. Anyway, I decided to build this weather station because last year my garden did not do so well. Maybe it was cloudy and more wet than usual. There was not enough sun. So my corn, garlic, and even snap peas did not produce well. But I had a lot of kale, raspberries, tomatoes, lettuce, cilantro, so I must have done something right. Maybe it is a matter of placing the right plant in the right environment for it. I looked for a weather station on Amazon and did not find one that would work for me. What is commonly available is temperature and humidity monitor, but it does not record the data and there is no light quality information. I decided that I need to build my own to collect data on these three main contributors to healthy plant growth. In my garden, I have a greenhouse, raised planter beds, container planters, and a grow chamber, which acts like a nursery. The grow chamber is all LED grow lights only. As I said earlier, my weather station would have light quality, temperature, and humidity sensor. Since I want to log this data, I choose to use a SD card module for storage. This will be my first time working with these parts, so it is also a process of discovery for me. There are a lot of schematics and code examples out there. All I had to do was a lot of Googling and then piecing the parts together to make hardware and firmware. The display module is added so that I can read the sensor's data while the station is running. I have included a video to show how this weather station works in my greenhouse. I tried a few arrangements until I got to this. I hope you like the illustration that shows where each module is placed. Maybe I should have used a longer breadboard. By the way, I did try to use a 9-volt rechargeable NiCad battery. It only ran for 2 hours. It could be that the backlit LCD display uses too much power. So I switched to using the adapted USB power, which then required me to run a long outdoor extension cord to wherever I place this station. Having built the hardware, now let's look at firmware development. Before I start, I look for libraries that are available for each sensor and the SD card module. This is a list of all the libraries that I have used in this weather station. In addition, I use a timelib.h for timekeeping. So why do we need timekeeping? For the purpose of recording daylight time and light intensity at timed intervals. That's why I use the timekeeper for. Instead of a firmware timekeeper, I could have bought a real-time clock module, so-called the RTC module. It would have been a lot easier for sure, but since I did not buy it, I used the firmware timekeeper. I did not want to log every single data point. Too much data is not meaningful, I think. So I decided only to save data at 5 minutes interval. For now, that worked for me. But I did want to see the sensors read out continuously. So each sensor data is displayed for 1 second. After using this weather station for a while, maybe I will change my mind and log more data points. Or I might change the sensor data to be displayed in every 2 seconds instead. That would be an easy change down the road. Because I am not using a real-time clock module, my setup does not know what is the actual date or time it is operating in. I experimented to use the serial port on my laptop to set CPU time on startup. So there is this code section that works, but I don't use it because it requires the station to be hooked up to the laptop with a USB cord on startup, which means that I have to bring the laptop to the location where I'm going to set the station. It is not worth the trouble, I think. So later I choose to add a software section to post-process the data that is collected. This means that instead of bringing my laptop, I take a picture with my phone, which will then give me a timestamp when this started. I use TCL/TK a lot in my work, so writing a GUI is easy for me. Maybe I should consider to teach programming. Anyway, here is a view of the GUI with data.txt loaded. At this point, this is the raw data from the SD card. In the first column, it is the time in milliseconds when this set of readings was recorded. Second column is the light reading in lumens, followed by humidity, then temperature in Celsius, and then temperature in Fahrenheit. In the boxes for date and time, I entered the starting information that was recorded on my phone and clicked update. Now you can see that the first column information has changed into a string of numbers, starting with the date and ending with the time in 24-hour format. It shows the samples were taken at 5 minutes interval, just as I had planned. Finally, I saved this process data into a file name that shows where it was collected and the starting date of collection. I may have multiple sets of data for the same location later, so I need the file names to be unique and yet understandable. Now, let's compare raw data to processed data that is saved. Notice that there are some text inserted in lines between data sets. See, so a lot of data has been recorded, but I want to know when daylight starts and when nighttime starts. So I also wanted to add computed daily light integral, max and mean temperatures. So what is DLI? I recommend that you use Google for a scientific answer, but the quick answer is that this is a number that is used by commercial seed sellers as an indicator to the amount of light protons required by the crop to yield optimal quality and quantity. Also, according to my research, lumens is reported by the light sensor needs to be adjusted for the type of light. Light source can be sunlight or grow light, and every type of grow light has different protons to lumens rating. These computed numbers are in the last two columns of process data. Anyway, back to my point about data. I wrote the program such that when it detects nightfall, it will print a summary of daylight hours information. Alright, are you going to build your own weather station? If you do, let me know what different choices you make. For the most part, I have not met many people who likes to program in TCL/TK. You can definitely do this with Python or C++ or whatever your choice of language is. For the hardware, you might go with Raspberry Pi or some other microcontrollers. There are just so many options. Till the next time, ta-da!